Okay, it's recording. Yesterday we derived the formula, the quadratic formula. We said that if you have a quadratic equation, ax squared plus bx plus c is equal to 0. This is a quadratic equation in standard form. You can make x the subject of the formula by completing the square on this formula. And when we did that, we ended up with x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So I said yesterday, I think most of you are familiar with this formula. You did it in high school, you just maybe didn't know where it came from. So it's not a very difficult formula to derive. And you can just use it if you know what A, B, and C are, then you can just use it to work out the value of x. So we did one example yesterday, or a couple of examples yesterday. Let's look at some more. So we have 2x plus 3 over 2. This is equal to x squared. So we have to solve this, but we have to use the quadratic formula. So first thing we need to do is write it in standard form. Now in standard form, I must have everything on one side and 0 on the other side. Okay, let's do that. So I can rewrite it as x squared minus 2x minus 3 over 2, and this is equal to 0. Okay, then I identify my a, b, and c. So a over here is 1 because the coefficient of x squared is an invisible 1 that is not written. B, the coefficient is negative 2, so we say that the sign in front of the number goes with the number. And then c is negative 3 over 2. So that is your c. Now that you know what your a, b, and c are, all you have to do is substitute them. You have x, this is equal to negative of negative 2. Remember, negative b doesn't mean your answer is a negative number. Negative b just means multiply b by negative 1. So negative b can be positive. Then plus or minus the square root of b squared, which is minus 2 squared minus 4 times a, which is 1, and then times negative 3 over 2. So this is all under the same square root. Okay. And then there's negative 3 over 2. So remember, this is all under one square root. Square root continues there. And then this is divided by 2 times a, which is 1. This you can just do on your calculator, very simple to do. We have x is equal to 2 plus or minus 2 squared is 4. 4 times 1 times negative 3 over 2. That is 12. Okay, and then 12. 4 times 3 is 12 divided by 2 is 6. 6 plus 4 is 10. Okay, so the square root of 10. Then you divide this by 2. So you'll have two solutions. I will write the exact forms. We'll have x is equal to 2 plus the square root of 10 over 2, and or x is equal to 2 minus the square root of 10 over 2. So those are my two values. So this is the exact form. If the question tells you to write it to 3 decimal places, that you can easily work out on your calculator. Then number 2, we have 3 minus 2t. That's number 2. 3 minus 2t is equal to t squared. So our quadratic equations need not be in terms of x. It can be any other variable, and not even just the English letters. We could use the Greek ones, alpha, beta, theta, and so on. The principle is the same, so it doesn't matter what your variable is. If you're using the quadratic formula, first you must rewrite it in standard form. So if I have it the way it is over here, I cannot say my a is 1, my b is -2, and c is 3. That will not be correct. It must be in standard form because we read a, b, and c in the formula from when it is in standard form. Okay, so t squared plus 2t minus 3, and this is equal to 0. So now it is in standard form. Then I can say a is 1, b is 2, and c is -3. So I know my values of a, b, and c. All I need to do is substitute them into the formula. So I will say t. So t, it's always your variable, it's not x. T is equal to a negative b, which is -2 plus or minus the square root of b squared, which is 2 minus 4 times a, which is 1, times c, which is -3. And then this is all divided by 2 times a, which is 1. Okay, simplifying this, we get -2 plus or minus under the square root. I have 2 squared, which is 4, minus 4 times -3, which is 12. So I have 4 plus 12, that is 16. And then this is divided by 2. So this is -2 plus or minus 4 over 2. Then I can write my two values of t. I have t is equal to -2 plus 4 over 2. And this is just 1, because it's -2 plus 4, that is +2, divided by 2, I get 1. And then the second one, I have -2 minus 4 divided by 2. This should be -3. Okay, so -2 minus 4 is -6, divided by 2, I get -3. Okay, and the others, you would work them out in the same way, because this is not very difficult to do. It's just knowing what your a, b, and c are, and then substituting them correctly into your equation. Then we have what is known as the discriminant. This value here, b squared minus 4ac, this is called the discriminant. So this is in the formula. We have x is equal to -b plus or minus the square root b squared minus 4ac divided by 2a. Now this part, that is what we call the discriminant. Now from the discriminant we can determine the nature of the roots. So it helps us determine Okay, so remember what we said the roots are. We said the solutions are sometimes also called the roots. So in this case here, we'll say 1 and minus 3. These are our roots. Okay, so the discriminant will tell us what kind of roots we have. Okay, so depending on what the discriminant value is, you can tell what kind of roots you will have. Now, the first scenario is when you have a discriminant b squared minus 4ac, which is greater than 0. Greater than 0 means that it is a positive number. Okay, now when your discriminant is positive, this means that you will have two distinct real roots. Okay, so you will have two distinct real roots. For example, here I have two distinct means they are different, they're not the same. 1 and minus 3 are not the same. I have two of them, and both of these are real numbers. So that is the first scenario. The second one is when b squared minus 4ac is equal to 0. If this happens, then you will have one root, and this is a repeated root actually. So what this means is you will have something like this. Your first x is equal to 5 maybe, and then the second one is also equal to 5 as well. So we get this when we have equations like x plus 1 when we have x minus 5 squared, this is equal to 0. If you were to solve this, you can rewrite it as x minus 5. X minus 5 is equal to 0. This means x minus 5 is equal to 0, or x minus 5 is equal to 0. So I will get x is equal to 5 from both equations, right? So if I were to expand this, you will notice that my discriminant is equal to 0. So when your discriminant is equal to 0, there is only one solution, and it is a repeated root or two repeated roots. And then the last case, number 3, is when your discriminant b squared minus 4ac is negative. That means it is less than 0. Now when it is less than 0, this means you have two complex roots, and these two roots are conjugates of each other. Okay, so complex, that means they are not real numbers. And conjugates, if you remember, when I have a plus bi, the conjugate of that is a minus bi, right? So remember all of that, where I is equal to the square root of minus 1. So these are the three possibilities that we can get. There's nothing else. Either your discriminant, which is a number, is greater than 0, equal to 0, or less than 0. And then from there, you should be able to tell me how many roots you have without working them out, and the nature of those roots. So if we look at an example, we have this equation, x squared minus 4x plus 1 is equal to 0. And I need to determine the number of roots that the number of roots, or the nature of the roots. So let me say the nature of the roots. That's the question. So to do that, I do not need to solve it. I just need to work out the value of the discriminant. The discriminant is b squared minus 4ac. Now b here is negative 4. So I have negative 4 squared, and then minus 4. A is 2, and c is 1. Okay, so this, you work it out on your calculator. 4 squared is 16, minus 4 times 2, that is 16 minus 8, and this is equal to 8. And then you look at the answer that you've gotten, it's 8. 8 we know is positive, it is greater than 0. So we go to our table with our discriminant. So here we are. If our discriminant is greater than 0, that means we have 2 distinct real roots. So this equation I can conclude so there's 2 of them. They are distinct and real. So 3 things about the roots that we can say. There's 2 of them, they are distinct and they are real. And we can actually work it out and see that that is the case. So here we're just checking if that is the case. Our equation was 2x squared minus 4x plus 1. Just using the quadratic formula, I have x is equal to minus b, which is minus negative 4 plus or minus. Now under the square root, I have the discriminant b squared minus 4ac, and I already worked it out over here. The answer I got is 8. So just to save space, I will put the 8 over there, and then I divide by 2 times a, which is 2. So what I have is 4 plus or minus the square root of 8 divided by 4. And I will have x is equal to 4 plus the square root of 8 over 4, or x is equal to 4 minus the square root of 8 over 4. So you can see that both of these, 2 of them, they are real numbers. There is 2 of them, and they are distinct, they are different. Okay, because the first one and the second one, they're not equal, right? So the discriminant actually told us the truth. Let's look at another one. We have 3x squared minus 6x plus 1. This is equal to 0. We have to again determine the nature of the roots. So to do that, we have b squared minus 4ac. This is equal to b, which is minus 6 squared minus 4 times a, which is 3, times c, which is 1. And this, work it out, 6 squared is 36. 36 minus 12, I think you get 24. Okay, and 24 is greater than 0. Then from there I can say I have 2 distinct real roots. Okay. Another one, 2x squared minus 4x plus 2 is equal to 0. So my discriminant, b squared minus 4ac, this is negative 4 squared minus 4 times a times c, which is 2. So I have negative 4 squared, that's 16. 4 times 2, 8 times 2 is 16. So I have 16 minus 16. This is equal to 0. And when my discriminant is equal to 0, remember back over here, we said it means I have one root only. Okay, this is a real root, by the way. So I have one real root. And then the last one, we have 2x squared minus 4x plus 3. This is equal to 0. Then again, my discriminant, b squared minus 4ac. This is equal to minus 4 squared minus 4 times a, which is 2, then times c, which is 3. So I have 16 minus 24. And this is equal to negative 8. Negative 8 is less than 0. So I know that I will have two roots. They will be complex and they are conjugates of each other. Okay, so that's how we use the discriminant to tell us what kind of roots that we have. So it's pretty simple. Then to finish off on quadratic equations, or the simple ones, we have word problems. So again, with these word problems, what you need to do is make sure you read the questions correctly and understand the information, because from the words you will have to come up with an equation and then solve it. So if the equation you come up with is not correct, then no matter how you solve it, your answer will be wrong. So make sure you read the question and understand the information that is given. So the first one says that you have, it says the sum of a number and its reciprocal is 13 over 6. What are the numbers? This is a question from your notes, so you can follow along. It says that the sum of a number and its reciprocal is 13 over 6. Then what is the number? Okay, so you have a number. When you add it to its reciprocal, the answer you get is 13 over 6. And now you're asked to work out what that number is. So you need to know what the reciprocal of a number is. A reciprocal, for example, if you have half, this is a fraction. The reciprocal of half is simply this 2 over 1. You invert the fraction. The numerator becomes the denominator and the denominator becomes the numerator. Okay, so you just invert it. Okay, so if I have an unknown number, we call it x, and then I add it to its reciprocal. The reciprocal of x is just 1 over x, because this x is the same as x over 1. So its reciprocal is obviously 1 over x. Now when I add these two numbers together, what I get is 13 over 6. Now I need to work out what that number is. So to do this, if you remember, we don't like to have fractions. We try and get rid of them by multiplying by the lowest common multiple of the denominator. So the lowest common multiple of the denominators, I have x and I have 6. The lowest common multiple of x and 6 is 6x. So I will multiply everything by 6x. So this one times 6x times 6x times 6x. And you can see these two will cancel. I'll be left with x. No, they will not cancel. It's this ones that will cancel. I will be left with 6, and the 6 over there will cancel. Then I write down what I have left. Here I will have 6x squared plus 6. This is equal to 13x. Now this is a quadratic equation. You can rewrite it so that everything is on one side. So you have 6x squared minus 13x plus 6. This is equal to 0. Okay, so we will solve this by completing the square. When we complete the square, we said first you need to divide throughout by the coefficient of x squared. So I'll divide by 6, divide by 6, divide by 6, divide by 6. I have x squared minus 13 over 6 plus 1. This is equal to 0. Then I need to figure out what term is missing from these two in order for my square to be complete. So I can rewrite it like that. So I need to figure out what I need to write on both sides. And we said to do that, all you need to do is take your coefficient of x, then you divide it by 2, and then you square it. So when I do that, I will have negative 13 over 12 squared, and this is just equal to 169 over 144. So that is what I'm going to add on both sides, and then my square on the left hand side will be complete. So I will have this x squared minus 13 over 6x plus 169 over 144. This is equal to negative 1 plus 169 over 144. So that's what I have. Then my square is now complete on the left hand side. So I open the bracket, I put an x. Then to work out what I put over here, I said I take this term the way it is. So this is minus 13 over 12, and then I square it. Then on the right hand side, I just combine those two terms, negative 1 plus 169 over 144. I should have 25 over 144. Then to solve for x, I get rid of the square by taking square root on both sides. I have x minus 13 over 12. This is plus or minus the square root of 25 over 144. So x will be 13 over 12 plus or minus 5 over 12. I work this out. The first x, this is 13 plus 5 over 12. So I can combine them under a single fraction because the denominators are the same. This is 18 over 12, and 18 over 12 is 3 over 2. And then x can also equal to 13 minus 5 divided by 12. 13 minus 5 is 8, and then 8 divided by 12 is just 2 over 3. Okay, so these are the possible values of your number x. So you can say x is either 3 over 2 or 2 over 3. And here you can see that if x is 3 over 2, then its reciprocal is 2 over 3. Then when I add them, I will get the sum 13 over 6. And if it is 2 over 3, then its reciprocal is 3 over 2. And again, when I add them, I get the same answer. So that is how we would solve that one. So very important that you read the question correctly, you understand it, come up with a quadratic equation, and then solve it. Then the next one, we're told that the sum of two numbers is 20, and the product of the two numbers is 96. Then we have to work out what the two numbers are. So we did this when we were talking about linear equations. We said come up with an equation. You should be able to rewrite a sentence in mathematical form. So when we say a sum of two numbers is 20, this means that if my two numbers are x and y, then x plus y is equal to 20. And the product means multiplication. So I have x times y is equal to 96. And just like we did with linear equations, we would write one of the variables in terms of the other and then substitute it into another equation. So here I will say from this one over here, I will say x is equal to 20 minus y. And then what I will do is this 20 minus y, I will substitute it over there so that I have one equation with one variable that I can solve. So I have 20 minus y times y. So this part here is x times y. This is equal to 96. So you multiply this out, you have 20y minus y squared. This is equal to 96. Then writing it in standard form, y squared minus 20y plus 96. This is equal to 0. Okay, so this can be factorized. So you look for two numbers that when you multiply them, the answer is 96. And when you add them, the answer is negative 20. And those two numbers are negative 12 and negative 8. So I will factorize this one. So you'll notice I'm using different methods with different questions. That is to practice all the methods, because you cannot say I'm just going to use the quadratic formula. The question can tell you which method to use, so you need to be familiar and comfortable with using any of the methods. So try solving one equation with all three and see that you get the same answers. So I put my y there, and I say my two numbers are negative 12 and negative 8, then I have two terms multiplying, is that one and that one. And because the answer is 0, only when it is equal to 0 can I then say y minus 12 is equal to 0. Yeah?
I can't see the screen anymore.
Is it just her who cannot see the screen? Or everybody cannot see the screen?
I can see the screen.
Okay, people are saying they can see the screen.
It went off when you started doing the sum of two numbers is equals to 20 and the product is 96. I can't see it from there.
Okay, everybody says they can see it. So it's like it's just you who cannot see it. So, but don't worry. It looks like I'm still recording. Nobody's recording over me. So I will post this and you can see. Okay, so then we have y minus 8 is equal to 0. And this means that y is equal to 12 or y is equal to 8. Then you need to work out the value of x. Now if y is 12, this means that x is equal to 8 because I use this equation. Let me not skip it, let me just write it. So we know that x is equal to 20 minus y. So this is 20 minus 12. I will get x is equal to 8. And then when y is equal to 8, this means that x is equal to 20 minus 8, and this is equal to 12. Now this solutions, these are pairs, okay? So you don't just say x is 8, 12, y is 12, 8. No, you must say when x is this, then y is this, because they are a pair. So you can write them as coordinates. So you can say your solutions is x is the first one, so it's 8, 12, or 12 and 8. Okay, so what I do not want to see is this. X is equal to 8 or 12. Then y is equal to 8 or 12. I know that x is either 8 or 12, and the same thing for y, but it's not just, they're not independent of each other. They go together. So I must see that when x is 8, then 12 is, then y is 12. And when y is 8, x is 12. They go together. So this, I do not want to see this. I will not give anybody any marks for that. So you must say the two numbers are either 8 and 12, or the two numbers are 12 and 8, like that. And then, let's see. Okay, so I think we can move on from that, because the word equations, it is just reading the question. And I'm sure once you have read it correctly, many of you can form the equation, and I don't think solving the equation is the problem. So again, try and use all three of the methods. Don't just be a specialist in one of them. Try and do all of them, because in the test I will tell you to use this specific method, so you should be comfortable with each of them. About the test, by the way, it is an online test. So what that means is I will send the test to you, or I'll post it on e-learning. It is going to be a 90-minute test. You will have 90 minutes to do it, and then 30 minutes to send it back. So to post it back on e-learning. If it is not posted within that time, that is the same as you not doing the assignment. You must write it by hand and then you must scan a copy back. So not a picture, it must be one PDF document that you send back. Okay, there are lots of scanning apps that you can download. Adobe Scan is personally my favorite because the scans come out really well, and when you post it on e-learning, I can mark it nicely. So please start downloading. You have about 2 weeks to prepare. So look for Adobe Scan. Let me write this. So here, Adobe Scan. Please download it. Make sure you try it before the day of the test. Make sure you have internet connection the day of the test. Make sure you submit it before it closes on e-learning. Okay, so you cannot say it is still loading because 30 minutes is more than enough time. The only problem you will have is if you do not stop when 90 minutes is up and you just continue writing until 2 hours is up and then you say, I'll send it now. Okay, so please get the scanning app and start preparing for the test. Okay, back to radical equations. Now, radical equations, these are
Ma'am,
questions. Yes,
ma'am, is this test 2 weeks from now or when is it?
it's on the, for now, it's on the 15th. That's 2 weeks from now, I believe. Is it not?
Ma'am, is it on everything we did?
I think that is in the course outline, what the test will be on.
Okay, ma'am.
So please read that course outline. It's your best friend. Okay, so yes, radical equations. These are equations that involve radicals. So we did radicals already. So these involve roots. We look at an example. So we have x is equal to the square root of x plus 2. So this is what we have, and then we have to solve for x. Now, first thing we will have to do with these equations is get rid of the radical, and we get rid of it by raising the power. Now, most of the time, the equations you get will just be square roots. So to get rid of a square root, you know you have to square both sides. But it is possible to have something like this, where you have the cube root. Okay, so you know if you want to get rid of a cube root, you must take the cube on both sides. So just know how to get rid of the radical. Now with this one, we take the square, we square both sides. So when I square both sides, I will have x squared. This is equal to the square root of x plus 2 squared. Then the square root and the squared cancel each other out. I will have x squared. This is equal to x plus 2. Now you can see I end up with a quadratic equation, so I'm going to solve it. This is x squared minus x minus 2. This is equal to 0. For this one, I'm going to use the quadratic formula. So my a is 1, b is minus 1, and c is minus 2. Okay, then I substitute. I get x is equal to minus b, which is minus negative 1, plus or minus the square root of b squared, which is minus 1 squared, minus 4 times a, which is 1, and then times minus 2, which is your c. And then this is all divided by 2 times a, just 2 times 1. Okay, so I have 1 plus or minus the square root of 9, I think. So that's 1, and then minus negative 8. Yeah, it's 9. And then this is 2. So I will have my first x. This is 1 plus 3 over 2. So this is 4 divided by 2, which is 2, or x is equal to 1 minus 3 over 2. So this is negative 2 divided by 2. This is negative 1. So those are my two solutions. Now when you get these solutions, you must always check, okay, and see if they do satisfy the equation. So just like we did with absolute values, we check on the left hand side and the right hand side of the original equation. So the original equation is this one over here. Okay, so it is not this one here. This is not the original equation. So substitute into the original equation. So I'll start when x is equal to 2. On the left hand side, I had x. So on the left hand side, I will just have 2. And then on the right hand side, I had the square root of x plus 2. So this is 2 plus 2. And this is just equal to the square root of 4, which is equal to 2. Then I compare the left hand side with the right hand side. Those two are equal. So I say left hand side is equal to the right hand side. Therefore, x equal to 2 is valid. So it's valid, or it is a solution, something to that effect. And then I try with x is equal to minus 1. And x is equal to minus 1 on the left hand side. I have x, so on the left hand side I will just have minus 1. And then on the right hand side I have the square root of x plus 2. So that's negative 1 plus 2. This is the square root of 1, which is equal to 1. Now these two are not equal. Then I can say my left hand side is not equal to my right hand side. Therefore, x equal to minus 1 is not a solution. Okay, so that is how I would write it. So you can see it is very important to check whether your solution is valid or not. Let's look at one more. Okay, so again here we have a square root and we want to get rid of it, and we say the way to get rid of it is to square, but do not always rush into squaring. If it is possible to isolate the square root on one side by itself, then that is the first thing you must do. Isolate it. So in doing that, I will have the square root of x minus 4. This is equal to 4 minus x. Then I square both sides. If I had squared both sides over here, you will notice that in the next step I will still have a square root, and that will make my work more difficult because I will then have to square again to get rid of that new square root. So isolate the square root as much as possible, if possible, and then what you do is you square both sides. So when I square both sides, I will have x minus 4. This is equal to 4 minus x squared. And I have x minus 4. This is equal to 4 times 4 is 16. 4 times minus x is minus 4x. Minus x times 4 is minus 4x. And then x times x is this x squared. Like that. So what I have is this x squared minus 8x plus 16 is equal to x minus 4. Then what I can do is bring everything to one side. So I will have x squared and subtract x on both sides. So I have minus 9x, and then add 4 on both sides, plus 20. This is equal to 0. And this one can be factorized. So I look for two numbers. When I multiply them, the answer is 20. And when I add them, the answer is minus 9. So the two numbers are negative 5 and negative 4. So we factorize. We have x and x. We say the two numbers, minus 5, minus 4. And the two brackets are multiplying. The answer is equal to 0. It means the first one, x minus 5, is equal to 0. Or the second one, x minus 4, is equal to 0. So this means x is equal to 5, or x is equal to 4. Then again, you always need to check, see if your solutions are valid. So you need to check. So I will start with x is equal to 5. If x is equal to 5, on the left hand side, what I have is x plus the square root of x minus 4. And this is 5 plus the square root of 1, and this is equal to 6. And then on the right hand side, I have 4. So 6 and 4 are obviously not equal. So left hand side is not equal to the right hand side. And therefore, x is equal to 5 is invalid. And then I do the same thing with x is equal to 4. I need to check and see that it is, whether or not it is a solution. So on the left hand side, when I substitute it, the left hand side has x, which is 4, plus the square root of x minus 4. So this is just 4 plus the square root of 0. This is equal to 4. Okay, and then on the right hand side, I had 4. So my left hand side and right hand side are equal. So I can conclude and therefore x equal to 4 is in fact a solution. Okay, so that is how we would do that one. So I will stop there. The next one is a bit long, so I don't want us to leave it halfway. Okay, so remember, tutorial test is on e-learning. Please make sure you do it before it closes. You just need to do at least one for the week. You can do more than one. Please follow the instructions on how to answer the questions. If it says leave it to 2 decimal places, and it says if necessary means it is not an integer, then it is necessary to write it as a decimal. Okay. Yeah, again, please download the scanning app well ahead of time. The test will not be difficult, so please study for it. Do we have any questions, or are we fine? Okay, if there are no questions and everybody is fine, have a good weekend. I will see you guys on Monday.